Hi guys. So today we're going to continue solving rational equations, but we're going to look at them in a little bit of a different light. We're going to shift our focus towards literal equations, which is going to lead us into inverses, and then we'll also look at inequalities. So to start, we're going to look at something called literal equations. So we've seen these a couple times this year when you have a whole bunch of variables and you're solving for a certain variable. You also may have seen these in your physics classes if you're in physics right now. So our goal here, you could write the same equation a couple different ways, the same problem. Instead of solving for R, I could solve for A, or I could solve for B. But whatever variable you're solving for, your answer is going to be in terms of some other variables. So our goal in this problem is to solve for R. Now, there is more than one way to solve this problem, whatever you think is going to be easiest. What I'm going to do in this case, I can either get a common denominator, or I can combine these together and cross multiply. So I'll try both. I'll start by combining these together and cross multiplying. So if I combine those together, a plus b over r is equal to a over r minus 1. If I cross multiply then, a times r is going to equal a plus b times r minus 1. That would mean that I have a times r minus a plus b times r minus b. And now my goal here is to solve for r. So if I'm trying to solve for r, what I need to do is I need to move everything with an r to the same side. So this has an r, this has an r, and this has an r. So I'm going to take all those and move them to, let's say move them to the right. They'll move to the left. So if I do ar and I subtract ar, well, that's going to go away. Then I'll move that br over. And this is what I'm left with. Now at this point, I'm trying to solve for r, so I need to divide by what's with it. And I get that r is equal to negative a minus b over negative b. Now, there's a couple different ways you could write this depending on how you solved it. Now, first of all, if I want, I could factor out that negative from the top. And then if you have that negative divided by negative, that's going to end up being a positive. You probably would have seen that same answer if you solved this a little bit differently. If instead of moving these terms to the left, if I moved them to the right, then I would get a plus b equals br. Then I would divide and I would get a plus b over b. Okay? This is equivalent, these two expressions are equivalent, okay? It's the same thing as negative a plus b over negative b. Any of those are okay, all right? All of those mean the same thing. But what we need to consider in this solution is what we cannot have be true. And what that is that b cannot equal 0 here because we can't divide by 0. All right, let's try another one. All right, we're going to solve for r. So on this one, I'll go ahead and get a common denominator. So that's the other method that we can use. So that common denominator, r1, r2, r3, and r are all different variables, which means that I'm going to need a common denominator of r1, r2, r3, and r. So that means that my left fraction is going to need to get multiplied by r2, r3, and r. The middle fraction is going to get multiplied by r1, r3, and r. The third fraction is going to get multiplied by r1, r2, and r. And then on the other side of the equal sign, that's going to get multiplied by r1, r2, and r3. All right, now all of these are over that common denominator, okay, of r1, r2, r3, r. But again, consider if we're trying to solve this, if we have a common denominator, we can just solve the numerators like we did last class. So this is the expression that we're dealing with now. Our goal is to solve for r. So again, let's take everything that has an r and move it to the same side. So I've got an r, and r, and an r. All right, so that's good. All those already have an r in them. So what I can do then, if every one of those terms has an r, I can factor that r out. If I factor it out, I'm going to be left with r2, r3. I'm going to be left with r1, r3, r1, r2. And then I'm going to divide by what's with r. Okay, let's pretend this equation was 3x equals 7. okay? This is my 3, sorry, that's my x. This is my 3, and this is my 7. To get it by itself, I would divide by what's with it. So I'm going to divide by that whole big long R2, R3, plus R1, R3, plus R1, R2. Same thing over here. Divide by that whole thing. And once I've done that, I'm going to run out of space, but you see what it is. This will cancel out when you divide, and you're left with R by itself. So I've got R1, R2, R3, all divided by R2, R3, plus R1, R3, plus R1, R2. And that's my final answer. So these can get a little messy. That's why it's really important, if you did not do the practice stuff from last class, you really want to make sure you spend some time doing that, because if you don't understand that process from last class, today is going to be really, really difficult for you, because again, these literal equations, we don't really have numbers, we're just following the same process that we did previously. All right, so if those are really tough, what I probably would recommend doing is trying these inverse questions first. So these inverse questions, these really are literal equations. It's just we only have 2 variables. We've got x and y. But we're still solving for one variable in terms of the other variable. We're solving for we're solving for y in terms of x. So if you don't remember, hopefully you do, because we've found this in a couple units now, the way we find an inverse is we switch x and y. So we're going to go ahead and switch x and y and solve for y. So x is equal to 3y minus 2 over y plus 7. So what I'm going to do here is I'm going to cross multiply. So 3y minus 2 is equal to xy plus 7x. Again, if I want to solve for y, I need to get all of my y's together. So I'm going to take everything that has a y and put it on one side. I'm going to take everything that doesn't have a y and move it to one side. So 3y minus xy is equal to 2 plus 7x. Now I can factor out the y from the left side, and I can divide by what's with it. So this is really the same process that we went through in the last question, but a little bit simpler to see. So I probably should have done this one first. I apologize, guys. Now, one thing you'll notice about these inverses, remember with inverses you switch x and y. That also switches domain and range. It switches all your x's and y's, which means your horizontal and vertical asymptotes really kind of flip. Okay, look at your original equation. This has a vertical asymptote at x equals -7 and a horizontal asymptote at y equals 3. Let's look at the inverse. Vertical asymptote at x equals 3, horizontal asymptote at y equals leading coefficient over leading coefficient, -7. So they flipped. All right, so now last thing we're going to look at are inequalities, okay? So we actually kind of touched on this idea when we talked about graphing. When we talked about picking test points and looking at the positives and negatives, that actually is the process we're going to use to solve inequalities. So this also can help you guys with graphing if you're trying to graph without a calculator. So whenever we solve inequalities, this is going to be a similar process that we use with polynomial inequalities and quadratic inequalities. What we do is we figure out where can my graph change from positive to negative. Typically that meant we found the zeros, or we found the x-intercepts. What we also have to consider for rational inequalities, though, is the vertical asymptotes, because your graph can switch from positive to negative following a vertical asymptote. So what we're going to do is we're going to find the vertical asymptotes and the zeros, and we'll mark them on a number line. Well, in this case, my vertical asymptote is at -7. My x-intercept is at 2/3. So those are the places where our graph could switch from positive to negative. So now we'll pick test points. So I'll pick some test point in this region, anything to the left of -7. Okay, if I pick a -5, or not -5, sorry, -15. 3 times -15 minus 2 is going to be a negative. -15 plus 7 is going to be a negative. And a negative divided by a negative is positive. Pick a test point in the middle region, like 0. 0 minus 2 is a negative. 0 plus 7 is a positive. A negative divided by a positive is a negative. Pick a test point in the last region, okay? 20. 3 times 20 minus 2 is positive. 20 plus 7 is positive, and a positive divided by a positive is positive. So now we just need to write our interval that answers our question. we want to know where this is less than or equal to 0. That means I'm looking for the negative regions. So my negative region is here. The biggest thing you need to be careful about is your parentheses and your brackets, okay? This is or equal to, so the 0 should have a bracket on it. But keep in mind, -7 wasn't a 0. -7 was a vertical asymptote. We're never going to touch -7. So even though this is an or equal to, -7 needs a parenthesis. 2/3 should have a bracket. This also gives you kind of a guideline of what this graph would look like. My graph is going to be positive everywhere to the left of -7. It'll be negative until that x-intercept, and then it'll continue positive up until that horizontal asymptote. So again, this is a good way to help you fix some test points when it comes to graphing. All right, the only other thing we need to consider is that when we're comparing these positive and negative values, it needs to be compared to 0. So if this is not equal to 0, we need to make it equal to 0. So I need to go ahead and add 2. And in order to actually add 2 and find that vertical, well, we can find the vertical asymptote, but in order to accurately find that 0, I'm going to combine these together into one fraction. So I'm going to multiply by x plus 2, top and bottom. So x minus 3 plus 2x plus 4 over x plus 2 is greater than 0. So that means I have 3x plus 1 over x plus 7. That means my vertical asymptote, I'll put my sign chart up here. -7 is my vertical asymptote, and -1/3 is my x-intercept. Pick some test points and plug them in. So anything to the left of -7, like a -10, okay, that would be a negative divided by a negative, which is positive. Something in the middle, like a -2. -2 minus 3 is a negative. I don't know why I picked, oh, there we go. Sorry, I'm looking at the wrong problem. So 3 times -2 plus 1 would be a negative. -2 plus 7 would be a positive. Negative divided by positive is negative. Anything to the right of -1/3, okay, 0. That would be positive over positive, which is positive. Use your sign chart to answer the question. I want to know where it's greater than 0, so I'm looking for the positive regions. Those positive regions are from -infinity to -7 and from -1/3 to infinity. All right, so that is it for today. Again, just a couple more little solving type applications. Again, those literal equations are really good practice. If you're really struggling with them, make sure you've done the actual solving questions the day before to really get that practice in, and it'll make some of those literal ones a little bit easier.